One of my favorite machines in the shop that we use quite often is this Coldsaw. It's essentially a big miter saw for cutting metal. So we can cut anything ferrous, non-ferrous. It uses a multi-tooth, I guess it's high-speed steel blade, and it can do miters. We can turn this either direction. This one actually will turn so far that I can slit down the middle of a piece of tubing. But as far as the capacity goes, I can take a piece of 3x3 steel and cut it at a 45, and very accurately too. The blade rotates fairly slowly, and there's a recirculating coolant, which is a water-soluble oil that comes down over the blade. And so it makes a very cool cut and really good quality cut. I mean, you can miter two pieces of tubing and just barely touch it with the edge of a file and put them together and TIG weld it together. It's really a handy saw. There's also coming out from here, we have an end stop so we can cut repeated lengths of material. I've also drilled and tapped this so that I've got a piece that I can put on here and put in multiple places to kind of work as an end stop for smaller diameter stuff. So today what I'm working on here is converting this to single phase. Right now, well, I've already converted it to single phase, but I'm going to do it a little better now. It's a three-phase motor, and originally it had I think a power switch, and then it had a speed switch, like a high-low. And I believe there's two sets of windings in the motor to give us two speeds. And then there's a switch here on the handle, and when you pull the switch, it would pull in a contactor and start the motor, turn the coolant pump on. But it's three-phase. I do have three-phase in the shop, but I prefer to operate this on single-phase using a variable speed drive. So right here I've got a VFD, variable frequency drive. This is not the first one I've put on here. A number of years ago when I first got the machine and I didn't have three-phase, I kind of welded this plate onto the side of here. I took all the guts out of the control, made this panel and put a couple more buttons, a couple new buttons in, and I had a Hitachi drive on it here. And that worked fine. You can change the speed, you can really get the blade speed dialed into where you want. But at that point, the roof of my shop was leaking, and one day we got some water leaked into it, and the drive failed. So it was always next to my vertical mill, and my vertical mill also has a variable frequency drive on it. So because we were lazy and didn't want to replace the VFD on this machine, we just wired it over to that machine and had a switch. So you could either turn it to the saw or to the mill. And we used it that way for a number of years. But now that I've renovated the shop, fixed all the roof leaks, I'd like to get this to where it's got its own drive and it operates well and looks good. So I bought this new drive. It is a Hitachi as well. This is a single phase input drive with a 3 horsepower output. Yeah, single phase input, 3 horsepower output, 2.2 kilowatts. So I believe this is called, yeah, the part number is 022B. So this is a 2.2 kilowatt, and I believe this is single phase input only. So basically what this does is it takes in the single phase AC, converts it all to DC, and then the output devices in this basically synthesize the output wave for the motor. And so we can control the output speed. We can also control how fast it ramps up and how fast it slows down. You can also put on there some current limiting and things like that. But for us, really all we're looking for is start, stop, and control the speed. So what I'm going to do, I don't want this up and out here. This just doesn't look very good. So I have bought a NEMA enclosure. So this has a seal on it, and it's got the door lock, and then in the back of it, it has a sub panel, and that is removable. That's just a steel panel that we can take out. So inside this, there's a coolant tank. It comes down to about about here. So I'm going to take this sub base out of here, and I'm going to mount this to the side of that enclosure. And then inside that, I'll mount the variable frequency drive, I'll mount a circuit breaker, I'll mount a power switch, which is also which is going to come through the front of our enclosure. I'll bring the power cord into that panel. Right now, the power cord comes into this, and the motor also comes into this. But we're going to bring the power directly into our equipment enclosure, and then from there we'll whip up to here. I think that we're going to have, for switches, I've got a couple options here. It really is nice to have the speed control. So I've got a potentiometer for speed, and I've got a couple different sets of switches. I have to decide what we want to use, but I've got two single buttons. I've got a red button and a green button that we could use for motor stop, motor start, and then I've also got one where it fits in one hole, and it's got like rectangular buttons. One says stop, one says start. So we can kind of lay that panel out, see what we like. This connector goes up to this switch here. I don't think that I want this to start my motor. I haven't ever had it that way, and so I'm not used to that. So what I think I'd like to make this for is for the coolant pump. You know, right now, like if this is up and you have the coolant going, the coolant tends to drip here towards the back, and it splashes all over. It's kind of messy. So I end up using this valve to throttle it on and off. You know, as I bring it down for a cut, I'll turn the coolant on, etc. So what I think I'd rather do is have the start-stop buttons control the motor and have this control my coolant pump. So I've got a small relay also that we will put down in here. And so this will control that relay. So the switch will control the relay, which will then control the coolant pump. And the coolant pump really is just it's a dishwasher pump that's down in there. So that way when you get ready to do your cut, you click that and the coolant will start flowing. So the same type of thing with the VFD and the on-off controls, you can apply really to any machine that has a three-phase motor that's 5 horsepower or less. I believe there's some 5 horsepower single-phase input VFDs, but 3 horsepower and lower is what you're going to most commonly find. So I've applied one to my vertical mill, and that's a great use case for a VFD because you've got full speed control, stop, start. I've also got on there a jog control, and so it really can wake up a machine. I would recommend a VFD over a 3-phase phase converter any day of the week. The phase converter is a one-trick pony. You're either you've got one with a rotary phase converter where there's a motor, and those are not efficient and they make noise, etc. And then there's also the static 3-phase converters, which don't really work very well and do not give you full output from your motor. So, and those are not free either. So if you're going to spend money to do phase conversion, I would much rather see you put a variable frequency drive with single-phase input onto a machine with a 3 horsepower or less motor. So we're going to do some layout on our control board. The box that we're putting in here, we'll do a little bit of cardboard aided design and get started on getting all of our devices put into the box and get the holes cut and things like that. All right, so I stripped out all of the old stuff from here that I'd made years ago. Control panel, it's got some switches, it's got the connector to the switch on the handle. Got that all off of there. I'd welded this plate on here, but we don't need that to mount the VFD anymore, so we're going to take that off. Here's the panel that comes into the back of that. It's got several leads to the motor. I'm not sure what this lead is for. It's a small diameter lead. This was not connected to anything. So I wonder if this was like a tack output or, well, the old one didn't have any kind of display on it, so I'm not sure, but we're going to find out what that is. Also, I figured out how they did the 2 speeds of the motor. On the back cap of the motor, it lists 2 different speeds, but then it also lists whether they're connected in delta or Y. So let's see. Because I've nutted the 3 of these together, it means they're probably in delta. Could be wrong there. And so this is what the 3 leads that goes to the VFD. The way I've got this is probably for the highest speed because I'm controlling the speed with the VFD. The way it's wired is, I think, the higher speed way. And then we've got a ground connection, the output out to the coolant pump, which went through this little fuse holder, which we'll keep. That'll give us some circuit protection on that. So we've got a couple different ways we could do this. I mean, of course, this is going to have the buttons in it for our control. It's going to have our e-stop, but we are not going to bring the power lead into this anymore. The power lead is going to go into our equipment enclosure on the side. That's going to have our disconnect switch. It's going to have our circuit breaker. It'll have the VFD. And then from there, we've got a choice. We could take the VFD output from that and go up here and go directly into the motor, which is, I think, my preference. Or we could bring everything from that enclosure back up into here, have another termination point in here, and then from there go out through these original wires to the motor. I'm not quite sure how we're going to do that yet, but I think the cleanest way is going to be to take these sets of wires out of this motor, put a new connection on there with our flexible conduit, and go directly down to our equipment enclosure. And then from this, go down to our equipment enclosure as well. That way, our equipment enclosure has all of our points going to it. We don't use this as a separate termination point. I think that might be cleaner. So to get this off of here, I'm going to have to grind and cut this weld off. So I think I'm going to take this whole thing off of the side of the enclosure. That way I can get this on the bench and grind it and make it look good. And then we'll try to find some hammer tone paint to match that up. And then when we make our front panel, maybe we'll do that in that hammer tone as well. So let's go to the bench and look at the stuff we're going to put in that enclosure and see how we're going to lay that out. Okay, so we've got our control enclosure. We've got some of our other pieces here. We've got our machinery wire, got some ground wire. We've got our service entrance cable. So this is what was on the old machine. We're going to reuse that. I'm going to put a different style cord grip on it, but we're going to reuse that. We've got our power connection that we're going to put in there. We've got some buttons. Got an e-stop button in contacts, and we've got our start-stop button in contacts. Those will go on the control panel, but you know, even at this stage, we've got to kind of be aware of what our inputs and outputs are going to be. Also have a relay block and plug-in relay. We're going to use this for our coolant pump. The switch that's on that is only a single pole switch. And also, it's probably not sufficient to directly control the coolant pump, so we're going to put it through a relay. So this panel is going to be mounted. This is the top side, and this is the front of the machine. So as you're standing at the machine, this is what you'd be seeing. You'd be seeing the front there, and then so back here, this is what goes to the back, towards the back of the machine. So I think I want to hinge it this way because this power switch interfaces with this disconnect via rod. So you can't put that over on this side. There's not enough room to get this to go in over that rod. You have to be 4 inches away from there. So, but this thing's so stinking huge. I can't believe this. It's 30 amp unit. But look at the inputs on that. I mean, you could put like 2 aught in that. So it's a little clunky. I'm not real happy with that, but essentially this, which shuts our panel here, is kind of in the wrong place. It's right in the middle. I don't really like it there. So what I think I'm going to do is take this out and use that hole to mount this, and then that can determine the position of this. And then I'll move this up because we do still need something to keep this closed. So I'll probably just move that up a little bit, or I can move it down. Probably move it down because this is going to be our on-off switch. So this has the legend on it, on-off, and it's got a place to do lockout, so you can do that. Put a padlock on it if you need to lock it out, and then also when you're on, it will not allow the cover to open. So kind of a general purpose machinery on-off switch, essentially, a disconnect. So that's our means of disconnect. So the power will come directly into that, and then out of that will go through this little 16 amp breaker. So this should protect the motor. This is the proper rating for that motor. And that mounts on a DIN rail. Got some regular standard profile DIN rail. So that will mount in there. And then the VFD will mount in there. Now, some of you may be saying, now why are you putting a VFD in a closed enclosure? Well, I don't think there's going to be much heat output from this. You know, the cold saw we don't put under a terrible amount of load. So we're going to play that by ear. I don't think I'll need any ventilation for the kind of intermittent duty cycle that we use the cold saw. I don't think this will be an issue. So, but I think I'm going to kind of put that over there. I think I'm wanting to bring the power input in down here. So we'll make a hole for that cord input. And then we're going to have two outputs here. One is going to go directly to the motor, and that'll be the motor connections to the VFD. And then the other one will go out to our front panel. And then it used to be that the coolant pump came out of this front panel. And so I think instead, since the coolant pump is inside the unit, we're just going to drill a hole through the back of this and eliminate that external connection to the coolant pump. Coolant pump doesn't need to have a flexible cord going up to this, which goes up and down with the saw. It just doesn't need to be there. And so we'll move that to inside here, and we'll end up putting our relay in here somewhere as well. So this is a little bit small. Now that I've got it and I'm looking at it, I say, boy, I wish I'd gotten a 12 by 16 or something like that, something with a little more space. But you know, we got what we got, and this is a 12 by 12 by 8-inch deep. So you know, they had a 6-inch deep, but I don't think a 6-inch would have done it, because you know, another 2 inches, I mean, it would have put that right up on there, and we don't really want that. So to kind of get started on this, I think we're going to take that out and get this thing mounted, and then we will adjust this position to be in the right place. We'll mount this, and then we can start mounting everything else. This back plate does come out, so after we get some of these things mounted, we can take that out. We can drill our holes for our other connections to get in there. It's good housekeeping in a machinery panel like this to have junction blocks that can mount on the DIN rail that then your wires go in and out of. That might be a luxury that we don't have space for in this, because it is pretty compact in there. And our control wiring is very simple. I mean, the power comes in, it goes through the disconnect, it goes from the disconnect to the circuit breaker right into the VFD. So I don't know that we need to be making stop-offs at junction blocks. So same thing with the control wiring. The control wiring is really going to come right out of here and right up to the buttons. So be nice to have some of that, but I don't know if we can afford the space. So we may have to bring in one little junction block for the ground, because we're going to bring our ground in from the power, and then we're going to bring some up to this unit, and then we're also going to go out of there to the motor. So or actually, we may not even need to do that, because we may just bring it, there's two places here to put a ground wire. So we may bring our power ground right in there, which is bonded to this, and then right out of there to our motor. So we may actually not even have to do that. So, but first step will be getting this thing on and moving our latch, I guess you'd call it. Okay, so I've made some progress here. I drilled some holes. I moved this latch from up here down to here, because I really wanted that hole to mount my on-off disconnect. So mounted that, moved this down to here. That's what locks the door closed. And I have mounted the disconnect, the circuit breaker, and the VFD. And I've cut down the actuation rod, and so it goes into this cone when you close the door, and then you can turn the machine on and off. So this is going to be what turns the machine on and off. You can take the back plate out, and you can see we've mounted that on there with some 832 or 1032 screws. Some are 832s and some are 1032s. So we've got those mounted on the sub plate. And that's nice because then you can take the sub plate off. So then inside here we have drilled some more holes and put in our power entry and then our 2 conduits that go out to the motor and to the control panel. So the power entry cord has this cord protector, radius protector on it, and then when this goes in, there's a rubber bushing that will grip onto the wire. So that'll do our strain relief and cord entry for that. And then for the other things, we're going to use, and I've already screwed these in here, we're going to use this corrugated flexible conduit. And this is great for machinery building. It's all plastic, flexible. There's several sizes, and then you have these entries for it. So this one I think is a half inch thread, so it'll screw into regular US boxes, and then you put that in there and screw it on, and once it's in, it's actually got little teeth. You can't take this out once it's in. So and these are fairly inexpensive. I get most of this stuff at automationdirect.com. So we'll end up having when this sits on the machine like this, power entry will be down here, and then this one will go up into directly to the motor, and then this one will go up and directly to the back of the operator console. So operator console, I'm not sure if we're going to keep this piece of metal or not. It's already got holes in it for the buttons. I've taken the old buttons off, and I've put this e-stop and this combo start stop on there, and so that shows you the panel. And then this would be for our relay to actuate the coolant. The only thing I don't have on here now is the speed control. So I may remake this because I don't really have a nice place for speed control. It would be nice to have the e-stop down there, and then maybe I would move this over a little bit, and I'd have the speed control right here. But I cannot find the potentiometer I bought for the speed control. I bought a potentiometer and a knob, and I cannot find them. So I may just have to punch the holes for them and remake the panel, punch the holes for them, and just leave that one open until I find the darn potentiometer. So, that's part of the control panel. So that comes a little bit later anyway. So really we're at the point now where we can take this to the machine, and we'll take the subplate out like this, take this to the machine, and we will drill 4 holes into the machine, and we can, I think we can get this bolted on the machine. I'm also going to drill a small hole back here. I'll do that before I put it on. I think it'll be up at the top. We're going to drill a small hole to pass through the wires that go to the coolant pump. Right now the coolant pump goes around the outside, the wire does, and really we don't need to because its relay is going to be in here, the power is in here, and so we'll just take it out the back. Okay, so we made some progress here. We've got all of our fittings drilled into our equipment enclosure. I've marked out, drilled and tapped 1/4 20, and I have fastened this to the side of there. I really wish I could have had this higher, but the coolant tank comes to about there. So if I had drilled into the coolant tank, we would have a bigger problem. So that's going to be where it lives. Our 220 entry is going to be right here. These are going to go up to the motor and up to the controller, and so we'll be able to tie those together with some tie wraps, I think, and that should look real nice. Now those do need to flex some because this goes up and down, and it also can turn around like that and like this. So we're going to figure out what our total range of motion is and make it so that this is long enough. I have the feeling that it's going to look extra long normally, but it'll make sense when we're all the way over to one side or another. So that's kind of what I'm working on right now. Also, I've changed my mind once again, which you're allowed to do, on how I'm going to do the coolant. This is the connector for the coolant pump. Now normally this went right back here, coolant pump's right there in the corner, and this went up to that control panel. Well, now that relay comes out of here. And so initially I was thinking I'd drill through the back of this and then bring a wire over here, and well, I've already got this connector coming out the back. I've already got this nice pigtail. Didn't feel like I should maybe bring that through there. So just one of those, you know, things you think about a couple different ways, and this is the way we're going to do it. So I've put in fitting back here for the smaller diameter conduit, and unfortunately there's no way to fit one of those fittings into here. The threads aren't the same. So what I think I'm going to do is I'm going to take some of that small conduit, this is just a little small piece, poke 2 holes in it, and I'll run a small zip tie through the hole and then back out again. And I'll get this up where I want it, and then I'll zip it, and that will hold that to the wire so it doesn't come off of there. So kind of right now we're going to figure out just how big this needs to be with that conduit. You know, it might need to be somewhere like that. This stuff is fairly cheap by the foot, so I'm not real concerned about wasting an inch or two here or there. And I love this stuff because it is super flexible. The other side of that equation, though, is that it is kind of hard to push wire through. So now I think we're going to try this with some little zip ties, see if we can get this to work out. This may be wishful thinking, we'll see here. All right. All right, there we go. Oh, that's not bad. So what I've got there is I've popped a hole through either side of one of these ribs, and I've got that through there. I'm going to get my wire down through there all the way, and then we'll give that a zippy zip. Okay, let's see here. Okay, so now we can get that pulled up there, and I can get this zip tied kind of in there. Hold on. Okay, get that pressed in there nice. So now that zip tie prevents this from coming off. So there we go. I like it. That's all that matters. Okay, so that plugs in, little screw goes on there. I've got some aircraft style single hole clamps, cushion clamps. I might, after we get this done, lay out, drill some holes, and bolt on some cushion clamps there. That would just make it look even better. In fact, we may not even need this much here. I'm going to take some of that off. Now, the first time I used this stuff, I mistakenly thought that I could get it back out of here. And the truth is, you just You just can't, at least with this brand of flex tubing. It's like there's maybe little backwards facing teeth in it. Could not get it out of there. So once you're committed, you're committed. And this ring actually rotates so you can hold the conduit steady and put the ring around. So, yeah, there we go. A couple clamps right there. Perfect. All right, so now we've got to kind of establish, I haven't done anything with the control panel yet, so we don't have that to put a conduit in, but I'd like to kind of establish our maximum travel of the head here. So to do that, I will clean this off a bit. Let's see, I believe it turns up to 45 degrees in this direction, but it'll turn all the way around in the other direction, which is not a feature that I use, but probably good to keep if we can. So this head will go, and it'll go all the way over to there to miter that direction. So in that direction, in that direction, let me get a piece of tape that we can put on there. My famous yellow layout tape here. So in that direction, we would want to go, I would say a minimum of maybe there. That would be our minimum for that. We got a good bend radius, etc. And then if we came back to 0, which is where it spends a good bit of its time, still reasonable. Now, that's just past 45 in that direction. And we're still okay there. Maybe need a little bit more. But then the real test is going to go all the way around to 90, which I don't know if I really care about, because it's not something I've ever done. Whew, I have a feeling that's going to be the killer there. Now, the only time I could figure you would do that is if you had a piece of tubing that you wanted to put a slit in the middle. And you could do that, but I don't see that as really being that useful. So that would take us way past our limit. So if we wanted to maintain all the capabilities, which means going all the way out to 90, we would need to be about there. So now let's go back and see if we hate it. Yeah, I don't hate it. I can live with it. There we go. Okay. Don't hate it. So, I am not going to put the wire, or excuse me, put this in there yet, because if I put this in there, it is going to make it really difficult to get the wires through that conduit. It's just kind of not sticky. I mean, it's kind of sticky on the inside, so it's very hard to push wires through it. I know this from experience. So it's much easier to make up. We'll estimate how long our wires need to be. We need UV and W for our 3 phases, plus a ground. So we'll have UVW, we'll mark those. Ground, we'll go ahead and get our little ring tongues on there to connect to the motor terminals. And then we're also going to make a little copper or brass or something bar to go across the bottom, a shorting bar essentially, to lock those together, because we're going to be in those 3 terminals down there just need to be bussed together. So we'll get those wires all made. We'll get it through all the way through here, plus our extra for in there. Then we can get the wires through there while it's straight. It's a lot easier to do that. And then we'll put that in there like that. So, but we've got a plan for this. This is all good. I did failed to mention here, I took this aluminum piece off here. There's 2 threaded connections, and that's where the old wire going in was, but it was a different thread. To thread my new connection in there, I needed a half NPT. So because this is just like a cast aluminum, I just threw it in the vise and just ran the half NPT tap through it, and this fitting goes in there fine. I will probably get or make a plug for this. I think this is probably what they call a PG type fitting, which is more of like a European, Japanese. So I'll get a PG blank to put in there, maybe a tiny bit of epoxy, and just plop that in there. So this one's going to go there, and then we'll have another conduit, pretty much exact same length, come out of there to the back of our control panel. So now that's the back of our control panel. There's a whole lot of holes in there that we just don't need. So I think what we're going to do is we're going to remake the back piece with just our single hole for our conduit fitting to go in, and then we're going to make a new front panel as well, I think, so that we can get our potentiometer on there for speed. So now I think we'll get these ready to go, and then I'll grind off the bracket from the old controller, and we'll see if we can get some hammer tone, some green hammer tone paint to match that. So. And then we'll wire it up. Okay, so we've got our wires back in the motor enclosure here. Before we had 6 wires because the harness went from here into the control panel, and then the control panel had a switch for high and low speed. And the way they control high and low speed is by either wiring the motor delta or Y. And so since I'm just using the high speed, I had 3 of the wires wire nutted together. So instead of bringing those wires all the way down to my enclosure and then wire nutting them together, I made a little copper bus bar to go across these 3 here, since these 3 are the only ones we used. So put new terminals on them. I've got them marked UV and W for my 3 phases. I've got my ground in there. And then we're ready to put that back on there. That's got to go on before we can put our control panel back on. So the control panel, we've taken it off and taken it over to the grinder, and I've ground off the flange that was there that I had welded on years ago for the first variable frequency drive. So I had to grind that off, and of course I kind of tore up the paint and the metal a little bit. So took it over to the TIG, and I filled in some of those openings, and now I think we could put that back on there. So let's get that control panel back on there, and then we'll make our next piece of conduit. Okay, so I've taken off the metal piece that I had here, finished it up, and sprayed it with some black hammer finish paint. So this has got a hammer finish here. So we're going to do a hammer finish on that just to kind of make it look the same. I couldn't find any pea green hammer finish, so this will have to do. So it's still a little bit soft, so I don't want to tear up this finish too much getting it in here. There we go. Got that on there. And then I've also made a new aluminum backplate for this. So I've put the connector on there for the switch, and I've also put our conduit fitting on there too. So that'll go in there like that, and then the switch connection will go on the back here. Really didn't want it on the front because that takes away from my button space. So let's see if we've got the right screws for that. Well, I've got some screws for it. We'll see if those are correct and if they line up. Looking pretty good. Okay. I've also made a new front panel and done some button layout on it, and that is drying. All right, not bad. Those wires are just barely long enough that we can make a connection on them. May end up putting a new wire on this, we'll see, because this wire is a little bit stretched there. Although, I guess that's really all it's ever got to do, so that's not bad. This was originally up front here. I just don't want it on the front anymore. We can do it back there. That'll work out okay. Okay, this is what we've come up with for our control panel. We've got the e-stop button, and we've got a combo stop-start, and then we've got a 0 to 10 potentiometer. It's actually a 1K potentiometer, but it's marked 0 to 10. It does not go to 11. So this is a new front panel that we made, and we've brought in some wiring from the control panel, or from the VFD. So usually with safety circuits, like with the e-stop and with a stop button, those are usually normally closed switches. So the red contact blocks are the normally closed switches, and the green one is a normally open switch. So the green one is our start button, and the red one is the stop button, and this one is the e-stop. So what that allows us to do is our stop circuit goes through the e-stop and then goes through the stop button. So what that means is if we push the e-stop down, the circuit is broken and it's in stop mode. And no amount of pushing the green start button will get it to get it to start. So the other reason they usually do that with safety circuits, you know, not only can you wire them in series like that, which is a logical and, this button and this button both have to be satisfied. Not only do they do it for that reason, but also if one of your wires were to come loose, it would prevent you from starting it, or it would stop it. So that gives you an extra measure of safety, because it's kind of like a built-in logic test. You can't even start it if it's in stop. So essentially, these switches are always being monitored. You wouldn't want to get into a situation where you started the motor and you weren't able to stop it. So our start-stop circuit is done with 3 wires. So there's a common that I've jumpered over, and then there's the start, and then there's the stop. This potentiometer has little screw terminals, which is nice, and we've just used some 22 shielded. This wire here is probably a little big for what we're doing, but it works fine. It just, I wish I had something a little bit smaller for that. The other thing we brought into here was we brought 2 wires in for the switch that is on the handle, and so that is for our that controls the relay, which controls the coolant pump. So looks like I'm missing one screw on this. Let's get this screwed in there, and then we'll look at the control panel and get this thing in operation. So this is the finished control panel. Inside we have all the components we need. We've got the first thing, power entry. We come into our disconnect switch, which this is actuated by the lever on the front. Then it goes from there into the circuit breaker, 2-pole circuit breaker. And then from there it goes into the variable frequency drive. It also jumpers over to these sets of contacts here. And one set goes to the coolant pump and comes back via the contacts on this relay. The other set goes to the switch on the handle and goes through to the activation coil of this relay. So essentially this relay is 240 volt activation, and it also outputs 240 volts to the coolant pump. But this can handle a much higher amperage than the small switch in the handle. We probably could have used the small switch in the handle to just operate the coolant pump directly, but I wasn't quite sure what the rating of that switch is, so I said let's throw a little contactor in there. So that's on an octal socket, so we can take this out if we want. It's kind of a neat relay. You can actually grab this and manually activate as well. And it has a little LED here, so it's really nice if you're troubleshooting, if you've got a bunch of relays where you can activate something and see if it works. So I got our ground, comes off of the VFD and goes to our to the motor, and then also to our coolant pump. We've got the UV and W motor leads going out to the motor. And then we have our activation wires here. So we've got the 3 wires for the potentiometer that controls motor speed. And then we've got common, input 1 and input 2. And so what I did was went into this Hitachi manual online for this. It's about 280 pages. And I looked through all the different activation styles, and I decided the one that I wanted to use was what they call 3-wire. It's really 4-wire because there's a common, and then that uses 1, 2, and 3. 3 being a forward and reverse switch. Now, we don't have any need on this to go reverse, so we're just using start button and the stop button. And the stop button is wired normally closed, so that completes our safety loop there. And then for the direction, we are just locking the direction in forward. So then you do have to do a little bit of programming to these to get them to do what you want. So what we're going to do here now is turn on the disconnect. There we go. You can hear the fan running. It's got a pretty healthy little fan in there. It sucks from down there and blows out the top. I hope we're not going to have any trouble with this with overheating. So to make changes to the programming, when you have the front panel here, you can go into these different menu modes. There's a D mode, F, A, B, and C as well. And H, okay. So there's very few things that we need to change. There's some things we need to change in the F mode, which would be the output speed and some of that sort of stuff. I've got a minimum speed, got a minimum and a maximum speed set, and I also have let's see, we got an acceleration set. So let's see, A1, 2. So this is our maximum output frequency. I think it was A3. So we've got a maximum output frequency of 60 hertz, but then I have 2 limits set. I've got I think my bottom limit is 15 hertz, my top limit is like 55 hertz. So when I leave this, I usually leave it in this D01 mode, and this displays the output frequency. So if I go up to my control panel and start, and then I can make some changes to, but it'll only go up to a max of 57, and it'll go to a minimum of 15. And then there's an acceleration timing. There's an acceleration and a deceleration timing. And so the acceleration timing, I believe I currently have set to 2 seconds, and the decel time is about 1.5 seconds. And you can play with that. But really this is fully programmed now. You won't see the display once it's closed up, but it's when you're playing around with it, it's nice to be able to see that. So there are a bunch of options for these VFDs for control. You just have to pick the one that's best suited to your machine. It's got the multiple input terminals there, and you could, for instance, set that up so that connecting a switch across input 1 would start the motor in forward and accelerate to 20 hertz. And then if you put 2 in, you could make it accelerate to 40 hertz. So, you could have essentially 3 buttons on the front of your console for speed 1, speed 2, speed 3, and then a stop. You could do that sort of thing. You could do speed controlled by the potentiometer like we're doing, or you could do speed controlled by just by a resistor, or you could do speed controlled by 4 to 20 milliamp current loop. So there's a lot of options for these. I mean, a ton of options. It's interesting also with this display here, you can also set a custom correction factor to change this from displaying a frequency, the output frequency in hertz, to displaying your motor output in RPM. So for instance, if you knew that your motor had a 4 to 1, let's say a 4 to 1 speed reduction, you could set a multiplier in here of 0.25, and what it would display would be the actual output RPM of your machine. Unless you have this display visible, I don't know that really helps you too much. And with what we're doing, we're going to just determine what our appropriate speed is with how it cuts and what it sounds like. But control panel is 100% done, and so we're going to close it up and let's see how this thing cuts. So the machine's pretty much finished now. We've retrofitted everything in that we need, got it programmed, buttons are in, new cables on it, disconnect switch, so now it's just time to try it. With that VFD in that enclosure, I can't really even hear the fan. Hopefully it won't overheat. So we'll have to do some testing. After a little bit of cutting, I'm going to see just what temperature it is in there. So got that on. Start button, stop button, and that turns our coolant on. Also have to open up the valve here, but that's going to be nice having that coolant not on all the time, because previously when I would turn the machine on, the coolant was just on, and so then I would have to manually do the valve every time I wanted to do a cut. So I have adjusted the jaws to be in the right position here. I've squared it up and tightened the vise down, and I've also set my bottom stop so that when I go through the material, the blade does not cut into the vise. And now I'll just kind of dial in the speed and get the coolant going how I like, and let's see how it cuts. And that is it. Perfect. So the cut that this makes is really nice. I mean, it's a great square cut, pretty much ready for welding. Usually what I'll do is I'll just clean that off with a little bit of maybe lacquer thinner or brake cleaner, something like that. And I usually don't even dress the edges down because I kind of want that for when I do my TIG welding. So that concludes our retrofit on this Scotchman Coldsaw, or Startrite Coldsaw. I think now with the success of this, I'm going to go back and do my vertical mill because it has kind of a similar setup with the VFD just out in the open, and it might be nice to put it in an enclosure as well, kind of amp it up a little bit. So I hope you enjoyed the video, and please leave me any comments or questions on the equipment used and anything like that. Thank you.